Hello everyone, this is Srikanth, working as assistant professor in electrical department. Here we have some problems on network topology or graph theory. In that we have incident matrix, dissect matrix and cut set matrix. In each circuit, we need to find out A, B, C matrix, incident matrix, cut set matrix as well as dissect matrix. For that, we need to draw circuit to graph. So before draw the circuit to graph, we need to mention, we need to identify number of nodes, number of branches. So for this circuit, we have 1, 2. So these are the 1 node, 2 node, 3 and 4, 5. So we have 5 nodes. So for this circuit, we have 5 nodes and branches. So 1, 2, 3, 4, 5, 6, 7, 8 branches. So nodes are 5 and branches are 8. So 1, 2, 3, 4, 5, 6, 7, 8 branches. First we need to identify the number of nodes, then branches. So we know number of nodes and branch. Then draw the graph. For that, just mention the nodes. So 1, 2, 3, 4 and 5. We have 5 nodes. So 1, 2, 3, 4 and 5. Then draw the lines. So where you have the passive elements, not only resistor, inductor, capacitor, there we need to give we need to draw one line. And where you have the sources, voltage source and current source, there we need to replace with their internal resistance. That means voltage source is short circuit and current source is open circuit. So in this circuit, we have voltage source as well as current source. So where you have the current source, that is open. So between 1 and 3 nodes, we have a current source. So no need to draw the line. Okay. And 1 and 4 have voltage source. We need to draw the line. Now check it. Here we have lines. So 1 and 2. Between 1 and 2, I have resistor. So I have one line. And between 2 and 4, I have resistor. So one line. And between 2 and 5, I have line. So between 2 and 5, I have line. And between 4 and 5, I have the resistor. Same thing, I have the line. And between 2 and 3, I have a resistor. So one line. And between 3 and 5, one resistor. Coming to sources. So voltage source between 1 and 4. So between 1 and 4, I have the line. So the short circuit. Now 1 and 3 have the current source. So current source is open circuit. So no need to draw the line. So this is my graph from this circuit. From this circuit, this is my graph. Clear? So give the directions and names. So any A, B, C, D, E, F, G. So how many nodes we have? So nodes are, for this graph we have 5 nodes and 7 branches. 5 nodes, 7 branches. Now give the direction, any direction. So I want to follow source direction. So source direction I given here. So any direction I given there some directions. Now for this graph too, I need to find out A matrix, incident matrix, B matrix, basic dissect matrix, and C matrix, basic cut set matrix. We need to find out 3 matrices. Now, so for this graph, for A matrix, so A matrix, no need to worry about original graph. That means tree and quote. Okay, so if you know the circuit to graph with directed graph, that is enough for your A matrix. So for A matrix, we have number of nodes into branches. This is your A matrix. So we need number of nodes and number of branches. So we know that from this graph, number of nodes is 5 and branches are 7. So your A matrix. So A matrix is number of nodes. So n1, n2, n3, n4, and n5. And branches A, B, C, D, E, F, and G. Now I want to give the values for each branch. So before writing a matrix, we need to know the directions. So for a particular node, so particular node 1, how many branches we have? So 2 branches. So for 2 branches, we need to give the values plus 1 or minus 1. Remaining branches, we have 0 values. So total 0, 1 and minus 1. The 3 values comes to in your matrix. So 0 for not connected branches and 1 for incoming currents. So node 1, if suppose node 2, I have A is incoming. At node 2, A is incoming. So A is incoming means A value is plus 1. And B, C and E. So B, D, C. B, D, E. 3 branches are outgoing. So we have the minus values. So when you are writing A matrix or B matrix, C matrix, we have 0, 1, minus 1. Only 3 values we have in that matrix. So 0 means not connected branches. And 1 and minus 1 are incoming currents. So which currents are incoming, which branch current are incoming, then we need to give that branch value is 1. Outgoing is minus 1. Now coming to node 1, at node 1, just observe at node 1. So we have 2 branches, A and C. Just give the values for A and C. Just give the values for A and C. So A is 1, C is 1. Remaining are zeros. Okay, remaining are zeros. Now check the directions. So at node 1, C is incoming and A is outgoing. So at C is plus 1 and A is minus 1. This is node 1 value. At node 1, we have A and C branches connected. So here A is there. A is outgoing current, so minus 1, and C is incoming current, it's plus 1, and remaining branches is not connected to that node, so we have the 0 value. Now coming to node 2, at node 2 we have 1, 2, 3, 4 branches. So A as well as B as well as D and E. So remaining are zeros. Now check the directions. So A is incoming. So A is incoming. Incoming means we have the positive one. And remaining D, E and B minus. So remaining are minus. So which is incoming current, that is positive. Remaining are minus. So this is about node 2. Coming to node 3. At node 3 we have again 2 branches and B is incoming, F is outgoing. At node 3 we have only 2, B and F. So B is incoming and F is outgoing, so minus. Remaining are zeros. So remaining branches currents are 0 and B incoming means plus 1 and F is outgoing minus 1. Coming to node 4, we have 3 branches, C, D and G. So at node 3, this is node 3, N3 and N2, N4 and N5. So node 4 we have 3 branches, that is C and D and G. Remaining are zeros. Now check the directions. So C is outgoing, so we have the minus value. And D is incoming, we have the plus value. And we have one more, G is incoming, we have the plus value. Coming to node 5, again we have the 3 branches. So G, E, F. So E is incoming and F also incoming, G is outgoing. So remaining are zeros. So E is incoming plus 1. So E is incoming 1 and F also incoming 1 and G is outgoing minus 1. That's it. So this is about A matrix. So from this graph, we can find out the A matrix when we know the number of nodes and number of branches and directions. So direction means incoming values. For particular node, the incoming values are positive, outgoing values are negative. and not connected branches are 0. Okay, so this is about A matrix. And here I want to discuss one more thing. When we know the A matrix, we can draw the graph also. So I know the A matrix. From this A matrix, I want to draw the graph. See now, when you are drawing the matrix to graph, then we require the branch values. So this is my branch. So branch, we need to follow the branch values. So this branch is connected between. Just observe. If you observe, you get the answer. So this A value is -1 and 1. -1 and 1. So between 1 and 2 nodes, A branch is connected. So suppose it's 1. So how many nodes we have? 1, 2, 3, 4, 5 nodes. So just 1 and 2. 1 and 2, I have one branch, A branch, and check the direction. So which direction I need to give? So at 1 it's minus, at node 1 it's minus, so it's outgoing from node 1, incoming to node 2. So node 2 has a positive value, so positive value for input. Now branch B between 2 and 3, so 2 and 3 I have the value, that is B branch, and check the direction. So direction is 2 is minus and 3 is positive, so 2 to 3. Okay, and C branch between 1 and 4. So 1 and 4, so this is 3. So suppose here 4. So 1 and 4, I have one more branch, that is C branch, and check the direction. So 1 is positive and 4 is negative. So 1, 2, 4 my direction. This is your C. Okay, and coming to like a D branch between 2 and 4. So 2 and 4 again I have one more branch, that is D branch, and direction. So 2 is -1 and 4 is positive. So 2 to 4 is direction. This is your D branch. Next, E branch between again 2 and 5. So from 2 to 5 I have one more line, suppose it's a 5, and check the direction. 2 to 5. 2 is minus and 5 is positive. So 2 to 5 my direction. Next, F branch between 3 and 5. So 3 and 5 I have the F branch. 3 and 5 are the F branch, and then check the direction. So 3 is minus. So 3 to 5 my direction. Next, G branch. So G branch between 4 and 5. So 4 and 5 are the G branch, and check the direction. So 5 is minus, 4 is direction. Okay. So from circuit to graph to matrix. But here we have the matrix to graph. Okay. When you know the A matrix, we can draw the graph also. But from graph to circuit, it's not possible. Why means here we have current source. So current source, which branch we don't. At voltage source also which don't know. We have only lines and directions. So using lines and direction, you can draw the A matrix, but we can't draw the circuit. Okay. So this is about the A matrix, and here we have one more thing. When I know like A matrix, suppose here I don't know like fifth node. So I don't know fifth node. Then I want to find out the fifth node values. So generally my matrix is 5 into 7 matrix. 5 into 7. In exam, we have like 1, 2, 3, 4. So he given only 4 node values, but we don't know like fifth node value. But I need to find out the fifth node and draw the graph. Okay, just observe here. If I want to find out fifth node values, means here coming to branch wise. So A branch we have the -1 and +1. So no need to require one more value. So for one branch we have 2 values, plus and minus. Only 2 values. Either one plus or minus. Remaining are no need to have any value. So remaining are zeros. So here we have -1 value, +1 value. So we have here 0 value. And coming to B branch, we have the minus value and plus value. So this is also 0. Coming to C branch, we have the minus value and plus value. We have a 0. Coming to D also, we have the minus value, plus value 0. And coming to E branch, we have the minus value. But in the branch values, we don't have the plus value. So we have here plus. And coming to F branch, we have minus value. Again, we require one plus value here. Coming to G branch, now we have plus value, we don't have minus value. So there is a minus value. So any matrix is given like 5 to 7, but here the values are only 1, 2, 3, 4 values. But I need to find out the fifth value and draw the graph. Okay, so fifth value means the summation of this branch values will get like 0. So here already we have minus 1 and plus 1. So in that fifth node, no need to connect that branch. At B branch, already connected between node 2 and node 3. So node 2 and node 3 already it's connected. So we have the 0 value. And at C branch, we have node 1 and node 4 already connected. So no need to have any value. But D branch, we have between 3 and 4 already connected. So 2 and 4 already connected. So no need to connect one more value. E branch connected only one node, that is like a node 2. So we have connected between node 5. So node 1, node 2 and node 5, that branch, E branch is connected. Same thing, F branch also connected node 3 and node 5. F branch also connected node 3 and node 5. Coming to G branch, connected between 4 and 5. Okay. So like that, we need to find out like minus value or plus value. Not given node values. So which node value we don't know, we can find out that node value also. Okay. This is about like A matrix. Now we are going to like B matrix. My graph is from that circuit. My graph is 1, 2, 3, 4, 5. Okay, 1, 2, 3, and 4 and 5 direction like that we have. Okay, A, B, C, D, E, F, and G. So this is my graph from that circuit. Now for this graph, I want to write the matrix B matrix as well as C matrix. So B matrix. So for that B matrix, we require virginal graph B and C matrix. For A matrix, the direction graph is enough, but B and C matrix we require virginal graph. Virginal graph means it contain co-tree and trees. So tree, for this branch we have 5 nodes and 7 branches, and trees, coming to trees, that is n minus 1 trees. So 5 minus 1, 4 trees, and co-trees links are B minus n plus 1, we have like 3. So remaining branches are co-trees. So we need to draw the virginal graph, means we require trees and co-trees. And for the drawing the trees, so I need to use 4 branches, any 4 branches. You can use any 4 branches. And there we have a small condition. There we have small condition, not connected. So need to connect, not connected, need to connect each node. So the 4 branches need to connect each node and should not in closed loop. Just observe here. So same circuit, 1, 2, 3 and 4, 5 branches. So 1, 2, 3, 4, 5 nodes. In that I want to use this 4 C and D and E and F. So these are my trees, C, D, E and F. These are my trees. Remaining are co-trees. So if you observe the trees, so they connected. So 4 branches connected to each node. So they connected to each node and should not in closed loop. So they are not in closed loop. So remainings are my co-trees. So A branch and B branch and G branch are my co-trees. Okay. Now I have the virginal graph. For this virginal graph, I want to draw the B matrix. I want to draw the B matrix. For B matrix, for B matrix, we need to use the links. So we have a circuit. In that, we have the virginal graph. From that virginal graph, we have trace and co-trace. In that co-trace, using that co-trace, we need to write the B matrix. So how many co-trace we have? We have 3. So for B matrix, your rows and columns are links into branches. So for this graph, we have 3 into 7 branches. This is your matrix. So for this B matrix, so 3, L1, L2 and L3. And coming to here, A, B, C, D, E, F, G are my branches. Now I want to find out the links. So links, using this link, I want to find out the B matrix. So how will you find the links? So for this virginal graph, I want to divide into 3 graphs. Why 3 means? So using only one co-tree, so only one link, and go for the one loop. So if observe here, we have 1, 2, 3 links are I have. So A is your co-tree, B is your co-tree, and G also your co-tree. So for A, I want to draw the graph now. Just observe 1, 2, 3, 4, 5. So this is my A branch loop. So A is my co-tree and this is my loop. So and C and D. So 1, 2, 3, 4, 5. Now observe clearly. So this is my original graph. In that original graph, I have A, B and G are my links. That is co-trees. Now using only one co-tree, I need to go for the one loop. In that loop, I need to add like only one co-tree branch. So now observe, A branch is your co-tree. Remaining branches are trees, not co-trees. So like that, we need to draw how many co-trees we have. That many graphs we need to draw. So this is A. Using A, this is my co-tree. If suppose in that, if I want like A and E, so I don't want like D. If I want like A, then E, then where I need to close? Again with co-tree. So it's not possible. If you observe in original graph, so I want to use like A, then E. Then I need to close. Close means we have like one co-tree. So in one graph that using one co-tree in that loop. So this is my loop 1. Suppose this is my loop 1. In that loop 1, you need to use only one co-tree and go with close. So here I have A branch. So 1 to 2. Okay. Then 2 to 5. Then 5 to 4. I have co-tree. So it's not closable. I need to use only one. Then I need to use like 1 to 2. Then 2 to 3 also is not possible. There we have one co-tree. So 1 to 2, 2 to 4, 4 to 6, 4 to 1. That is your one link. This is your one link. And coming to like a B also 2 to 3, 3 to 5 and 5 to 2. So this is my loop. Then coming to G, for G means 5 to 4, 4 to 2 and 2 to 5. This is my link. So we have 3 links. The direction also. So which direction I need to follow? So you need to follow the direction is your co-tree direction. So here we have the A direction. So A direction. Here co-tree A direction. Here B direction. And here G direction. Then write the values. So at loop 1, here we have the loop 1. For this loop 1, my values are A is in that loop. A branch is there, B branch is there, and C branch is there. So in that loop, I have A, B, and C. So 3 branches I have. So 3 branches values are 1. So we don't have remaining branches means 0. And check the direction. So A direction, then B direction. So A direction, B direction, and C direction. So in closed, same direction, the closed path direction is same. So same means everything is 1. Coming to second loop like b value. So for b value we have between 2, 3 and 5. So b is your co-tree and this is your tree and this is your tree. So 2, 3 and 5 have again 3 branches. So b and f and e. Now observe. So b and f and e. These are my values. So remaining a, c, d and g are my zeros. Now b is your code, so +1, and b direction and f direction both are same. So b, so 2 to 3, 3 to 5 is same, but 5 to 2 it's reverse. E is reverse compared to your b value. So e value is minus. Then coming to like loop 3, at loop 3 also between 4 and 5. So here we have J is your code. So 2, 4 and 5. Now check the directions. So E and D and G. Now I need to follow the G direction. So we have the G and D and E. These are my branches connected. So remaining branches values are 0. Now check the direction. D is your code tree. So 5 to 4. Then 4 to 2. 4 to 2 is reverse. So my direction is, this is my direction. But here D value is reverse. E value again same. E value same. So D is your minus value. Okay. This is the B matrix values. And here like A matrix, we can't add those values, we cannot 0. So A matrix is different, B matrix is different. So here the directions and links, depending upon direction and depending on links, we have the values. Okay, and here I have like C, D, E, F is trees. If suppose you want to draw another tree, so another trees means like that 1, 2, 3, 4, 5. So you want to use like a 1, 2, 3 and 4. This is also one tree. Here we remaining a core tree. So they connected each other and should not in closed loop. This is also one type of original graph. So depending upon your original graph, the B value will be there. Okay, and you can say these are the loop currents. So L1, L2, L3. These are the loop currents. So in your mesh analysis, we have the loop values. So I1, I2, I3. Same thing here. We have I1, I2, I3 values. Clear? So this is about the B matrix. Coming to C matrix, from that original graph. So 1, 2, 3 and 4, 5. This is my original graph. So this is my original graph, and those are trees, and like A and B and G are co-trees. So 1, 2, 3 and 4, 5. Here we have A, B, C, D, E and F. Last one is G. So this is my original graph. From this original graph, I want to find out the C matrix. So C matrix means cut set matrix. So I need to cut the trees. So your C matrix is number of trees into branches. So how many trees we have? 4 trees. And branches 7. So 4 by 7 matrix is your C matrix. So your C matrix is C1, C2, C3 and C4 as well. A, B, C, D, E, F, G. So this is your C matrix. Now I will go for the cuts. So how many trees we have? 4 trees. We need to use 4 cuts at any place. Okay. So I'm using here for C, D, E, F. I have 4 trees. For C tree, I want to cut here. Okay, you can cut at 4th place also, no problem. At 4th node also you can cut. But I will cut at node 1. Okay, and for D I want cut here at 2 place, so no, 4 place. Okay, you can cut any place at 2 also you can cut. So this is for C branch, and this is for like a D branch, so D tree, and here this is for E tree, and here I want to go, this is for F tree. So you can cut any place, no problem for that. You can cut at 5th node for F and 4th node for. So for which tree you are cutting, you need to take that direction. So suppose at first node I want C. C is my tree. So I will take the incoming branch currents are positive. And here I have a D branch. So here also incoming. So D is incoming. So incoming branch currents values are positive. And coming to here at 2, I'm using like E. So E means outgoing currents. So here we have outgoing current values. And coming to third node F is again outgoing. So you need to use the current direction which tree you are cutting there. So here with fourth node I'm cutting like D tree. So D tree direction is incoming direction. And at 2 node I'm using like a E tree. So E tree direction is outgoing. So outgoing currents are positive. C1, C2, C3 and C4. Now check the values now. So it's very simple. So at node 1, that means cut C. C1 I have 2 branches, that is C and A. 2 branches and incomings are positive. C is incoming. So at cut 1 incomings are positive. C is incoming, A is outgoing. So A is -1. Remaining branches are 0. Okay, coming to 4th node. At 4th node I have like incoming currents again. I am using like D branch, so incoming currents. So here C node connected, D and G. At 4th node I have C, D, G. C is outgoing, so -1. And D is incoming, whether +1. And G also incoming +1. So remaining are zeros. So why I'm using like incoming are means at incoming. So D I cut there at 4th node I cut D branch. So D branch is your tree. So the tree direction is incoming currents. So incoming means incoming currents are positive, remaining are outgoings are 0. Coming to node 2, so C3. At C3 we have 1, 2, 3, 4 branches A, B, D, E. So A, B, D, E are connected. Now remaining are 0. Now coming to direction, so E direction is outgoing. So outgoings are positive. So E is outgoing and here B also outgoing. So E and D outgoing and A is incoming. So A only incoming. So A only incoming and B, C, D are outgoing. So B, D, E are outgoing. So positive. So why outgoing are positive means your E branch. So E is your co-tree. So E is your tree. So tree direction is outgoing. So at this node, which current is outgoing, those values are positive. That branch values are positive. And coming to like C4, at C4 I have B and F. So B as well as F. So remaining are 0. Remaining are 0. Then here outgoing currents. So B only incoming and F is outgoing. F is outgoing. So we have the value. Okay. So for C matrix we need cuts. We need to cut the trees, not co-trees. So any place, not only particular place, you can cut any place, but which direction you want to take. So which tree we are cutting, that tree direction you need to take that node, particular node. So but node 1 I have like C's I am cutting. So C tree is incoming current to node 1. So incoming current are positive. At coming to node 2, so I am using like E tree. E tree current is outgoing. So at node 2 outgoing currents are positive. Okay, so like that we have the C matrix, basic cut set matrix. Here you can say node voltages. So you can, using this C matrix, you can find out the node voltage. So here we have 4 node and fifth node is reference node. Suppose fifth node is reference node, VR equal to 0. So from that we can find out the node voltage values. Okay, so this is about like a ABC matrix. So a particular circuit, you want to find out the ABC matrix means it's small processor. So you want to go for one more matrix, one more circuit. So here I have one more circuit. So for this circuit, I want to draw the original graph. Okay, so here we have how many nodes we have. So 1, 2, 3, and 4. If you consider these are the one node, no problem. If you not consider also no problem. Okay, so here 1, 2, 3, and 4 nodes. Just here right here 1, 2, 3, and 4. Okay, branches. So for this circuit we have the 4 nodes. Nodes are 4. Coming to branches. So 1, 2, 3, 4, 5, and 6 branches. So we have 6 branches. Okay, 4 nodes, 6 branches. Now I'll draw the original graph for this circuit. So from this circuit, first I will draw the graph. Now 192, I have one resistor. So 1, 2, 3, and 4 nodes. 192, I have the resistor, so I have the one line. And 2 and 3, I have one more resistor, so I have one more line. And 2 and 4, I have the resistor, so I have one line. And last, we have one more resistor. Between 3 and 4, I have one line. Okay, now sources. So 4 resistor, 4 lines completed, then sources. Here, voltage source between 1 and 4. So short circuited. 1 and 4, I have the short circuit. Coming to 2 and 3. 2 and 3, we have one current source, not voltage source. This is one current source. Okay, so but that is depending upon the another voltage source. But here we have the current source. So this is current. So voltage dependent current source. So it's a current source, but depending upon voltage source. So for that, this is a current source means we need to replace with internal resistance. So it's an open circuit. No need to draw the value. And give the directions, any direction. So I want to use like a source direction. So this is my directions. Now give the values for these branches A, B, C, D, and E. So we have like a branches. Now nodes. Number of nodes are 4 and branches are 5. 1, 2, 3, 4, 5 branches. For this graph we have 4 nodes, 5 branches. Then go for the original graph. So for original graph we require trees and links, co-trees. For trees we have n minus 1. So 4 minus 1 we have the 3, and co-trees b minus n plus 1 we have 2. Okay, so this is about trees and co-trees. Now just draw the original graph between same nodes 1, 2, 3, and 4, and 1, 2, 3, 4. Then your trees. How many trees we have? 3 trees. And what is the condition for trees? So should not in closed loop and need to connect each node. So I have the 3 branches. So I will draw like this. It's very simple. It's very simple. 3 lines. Okay. So C, D, and E. Remaining are co-trees. A as well as B. A and B. It's simple. So which branches you want to take for co-trees? Which branches you want to take for trees? So for trees we have the conditions. Use that condition, draw the trees. That's it. Remaining are co-trees. Very simple. Okay. And direction is as it is. Which direction you want to take? The same direction. For this we want to go for the A matrix or B matrix and C matrix. Very simple. So A matrix means we need to follow the number of nodes. So A matrix is n into B. number of nodes into B, and B matrix is number of links into B, and C matrix is number of cut sets, that means trees, into B. Branch is the same for A matrix number of nodes, and B matrix links, and C matrix trees. Now coming to nodes, at particular nodes incoming currents are positive and outgoing currents are negative. So for that A matrix, and B matrix we need to go for the links. So how many loops we have? So 2 loops. So 2 links we have. So 2 loops. We will get like 2 loops. So for that, for A also my A is your code tree and B is your code tree. So for the code tree, this is my loop. So when I'm going to loop, we need to use only one code tree. So I'm using a 1, 2, 2 to 4, 4 to 1. So this is my one loop. So loop 1. And B, this is my L2. So this is a B. So 2 to 3, 3 to 4, 4 to 2. So this is my one loop. So 1, 2 is my links. So your B matrix here is A matrix is number of nodes 4 into 5 matrix. Your B matrix is 2 into 5. And your C matrix, that is 3 into 5. 3 into 5 is your C matrix. So for C matrix, we can cut any place those trees. So how many trees we have? 3 trees. So you can cut tree like a C tree is here, and D tree is here, and E tree is here. So then check the direction for C1, C2 and C3. This is my incoming current. So your tree. So C tree incoming currents are positive. For that node incoming currents are positive, and here for C2 outgoing currents. Why outgoing currents? Your B tree. So your D tree is outgoing. Outgoing currents are positive. And coming to C3, that means cut 3. At node 3, we are using like E branch. E branch current is outgoing. So again, outgoing currents are positive. For ABC matrix, like that, we need to find out that ABC matrix. So any virginal graph you can use for B and C matrix. So any circuit to graph to your virginal graph, that means tree and co-tree, then A matrix, B matrix, C matrix, incident matrix, basic tie set matrix, basic cut set matrix. For incident matrix, we require number of nodes and branches and direction. That is enough for that A matrix. Coming to B matrix, we require code trees for code tree and loop. So using only one code tree, we need to go for the loop. So remaining branches are trees, then go for the loops and find out the loop direction. So which direction we are finding, and we need to write the B matrix. Coming to C matrix, we need to use the trees. So how many trees we have? So that many cuts we require for each tree at particular node. So those are node voltages. And coming to B matrix, we have the loop currents. Coming to C matrix, we have the node voltages. There the direction. So you need to take the 3 directions. So for a particular node, the tree is incoming means, so incoming branch currents are positive, and coming to like outgoings in any particular node. So here we have the second node, we have the outgoing current. So outgoings are positive. Okay. So like that, we need to draw circuit to graph to original graph to your matrix, incident matrix, tie set matrix, and cut set matrix. Okay. This is about small problems on network topology. If any queries, contact me in comment box. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.